Hello, everyone. Continuing on topic 8, supporting cognitive functions, and continuing from topic 8.1, we're still talking about attention. 8.1 talked about the models of attention, the varieties, the selective, divided, and focused attention concepts, and what we're interested in here. So now, how do we design for those sorts of varieties of attention? As we remember, we're still hanging out, at the top here. We're talking about the influence of attention on all of these steps in human information processing, but good to remember that's where we are. All right, so for now, we know a little bit about what attention is, roughly how it works, at least according to these models. Now, why are we talking about it, in this topic, in this class? Because we're designing for humans that are described by all of those characteristics of attention, and they're limited. So our ability to select from all of the possible things we could sense or we could perceive to this is the small set of all these stimuli that are most relevant to me, that I'm going to devote to my more precious, more limited cognitive resources. So, here's one example of an environment where there's more potentially available for the human system to process than they possibly can. And so there's a need to, what we say, guide attention. We direct or guide attention through interface design, through display design. So this cockpit involves several different ways that this pilot or that pilot's attention can be directed towards what is likely an important incoming event or message. So aircraft cockpit, process control, space operations, hospital settings, clinical settings, all of these are just examples of, look at the wealth of data that could potentially be relevant to whatever task I'm doing that's in this space. And then recognize that one human processor could never keep up with all of these data. And so we need technological solutions in our system to help guide that precious resource of the human attention. So now if we go back to and start talking, or resume talking about our varieties of attention, remember, selective attention is the guy with the searchlight and deciding where am I going to point this searchlight and how am I going to focus it. And so if we want the system around the guy with the searchlight to best support behavior, best support performance, safety, and all that, we need to keep in mind, well, where might certain aspects of the environment lead attention to be directed into a direction that we didn't intend. So these are some of my goofy joke examples. This one may be one of my favorites in terms of, well, how much of this visual scene are you going to extract and process before you act? And if you are a human, you likely search things top down, and I'll talk about left and right later in this lecture. But I would probably read this much and say, hey, I'm looking for Highway 35. Oh, it's that way, go. And I maybe wouldn't continue to process to see the rest of the important information in this stimulus, right? So yes, again, several examples where if your attention is extracting some aspects but not others, you could get you could have an error situation. All right, now selective attention, we have the ability to study this and to some extent to help the humans make sure that they select from their environment the most important things. We have two different types of influences. Both of these, let's put that now, both of these influences are present all the time, are guiding the orientation of our attention all the time. So I don't, just like with divided and focused attention, it's not like I'm in one state or the other. It's kind of like two extremes that describe the range of resources devoted to various tasks that I could be doing. Similarly, with top-down influences and selective attention and bottom-up influences and selective attention, which I'll talk about in a minute, each of these are present all the time. There isn't like top-down reasons maybe do this, bottom-up reasons maybe do that, and they're exclusive. They're both interplay, interrelated, competing for your attention continuously. All right. So these two categories, right? Top-down influences are a little easier for me to explain first because they're everything that comes from inside your head or the top of your body down is a good way to think about it, right? What this stands for is, what do I know about the context? Where do I think there are interesting things already? What are my expectations? What are my goals with this current search for information? So if I open the refrigerator, there's a lot of light, there's a lot of sensory data that I can take in as soon as I open the refrigerator, but I already sort of have some mental model about what's in the refrigerator, about what I might want to eat, about where those items are. And these are going to guide my search. So I open the refrigerator. I'm not starting at the top left and looking, all around. I'm going to look pretty close to where I think something I'm expecting might be. So that's one type of influence. My ability to control myself in terms of what I attend to. And then we have that influence. Bottom up. Okay, so the other type of influence is outside of me. I guess bottom up to contrast it from top down, although I always get confused with why do they call it top and bottom. Top is where the brain is, I guess, and so that's the way we do that. But what we mean by bottom up influences is how much the environment around the human has physical energies that stand out from the background and therefore attract attention in what we call a bottom up way. So, hopefully I wouldn't be expecting any sort of explosion to occur, over there in this room right now. So from a top down influence reason, I'm not continuously watching over there to see if an explosion might happen. But fortunately, as I'm talking to you here, my top down influences are keeping me focused here. If there is a large explosion outside, I'm not going to miss it. So I can stay, I'm intending to be talking here, but boom, loud, flash of light, things that stand out from the background, the more they stand out, the more we say they have this characteristic of salience. Great question, or I mean, great term to know for exam questions, this idea of salience. So I define that by saying, again, how much something stands out from the background in terms of some physical property. So a visual item might be brighter or a different color or more mobile, more dynamic. A sound may be louder or of a certain characteristic, in a certain vocal or audible range, for example. So again, the formal definition, I guess, is the state or condition of being prominent. I always think of it as how much does that stand out from the background in a measurable sense, if you could get the measurements. And that's what we talk about as our bottom up influences. So again, one more time, these are both continuously active. I might open the refrigerator, be thinking about chocolate cake, and therefore guide my own, visual search to look about where I think the cake is. And then while I'm looking at the cake, I could hear an explosion. And even though I'm really focused on this cake, this is what I'm interested in, my attention is going to be sucked to that external event if it's salient enough, right? All right. Now, okay, so how do we design for this? How do we take advantage of it, especially when we talk about displays and controls, which we recently have. So there's that keyword again, salience. So bottom up attention is drawn or is oriented in a display sense around the things that are salient. So again, these are large, bright, colorful, loud, changing, and really I've got this keyword unique. Okay, so any way it stands out from the background makes it like candy for your senses, right? So internet pages know this, and that's why internet ads are so loud, or visually loud, I should say. They are so bright and maybe visually obnoxious, but one thing they very much do is they draw your attention right to that source, and that's the purpose of an ad, right? So there are ways to direct attention to those things. Another very fun tangent here that I like to talk about is this is how stage magic works. It's one of the ways. So stage magic is really, I like to say it's like conducting attention. And in a lot of the same ways we can do Well, let's guide the human operator's attention in this interface. You've got these sneaky guys who are saying, let's like misdirect attention. And so one of my favorite things, like you can imagine this guy pulls a rabbit out of the hat, and at the same time, he has his beautiful assistant dancing next to him. And maybe there's a flash of light over there and a loud sound over there. It's really hard to maintain your attention focused on, I'm pretty sure he's going to do a little trick here in that hat, and I'm just going to stare at that hat. There are ways where if you're a skilled magician and people are looking right at you and they know you're about to do a trick, there are ways to direct everybody's attention in a way they cannot control and get away with a secret move. And one example would be have a huge explosion occur over there. That is something that people could not shut out. And even if it's just for a split second, that bottom-up attention influence is going to reorient their attention. So I like to do this. If we were live, I'd do a few tricks. I'm sure you'd be impressed. But one of the big things that I really like that magicians do, and I love to see it and point it out, is this. So if you're a normal human, which you all are, what happened just then is if you're looking at my video, you would have seen my hands move. So you would see the movement. Your visual attention is drawn to that. That's salient. And there is something hardwired about curvilinear motions and our visual system that makes it very hard to look away. So if I do a big circular motion with my hand, then I can do whatever I want with my other hand, and I can do something secret like pull a rabbit out of something. So there's a few things where you're looking right at me, I'm about to do a trick, and I'm about to try to fool you with something visually, and I can still get you to look away for a split second. And if I'm a skilled magician, that's enough time for me to do my little trick. All right, there you go. Now, when we're talking about bottom-up properties, it's important to remember it only matters the physical properties of that stimulus. The bottom-up orientation is all about what happens on our sensory level, okay? I have not interpreted that loud pressure change, that loud sound wave. I don't know what it was. It was an explosion, let's say. I don't know that it's an explosion. The reason that I'm attracted to it is because it's such a loud thing. I don't even know what it is yet, or it's such a bright thing, okay? So really doesn't consider the interpretation of the stimulus at all. It's just the physical properties of that stimulus define that bottom-up influence. Interesting note is that when things are present or when they become present, onset, so they turn on, that is a more salient, that's a more attention orienting effect than when those things disappear or turn off. So even though the visual scene might change, if I add something or if I subtract something, it has a stronger influence when we add something. And so then this is interesting because there's a lot of interfaces and displays where, and there are examples of this in like accident literature, where people don't notice the absence of something. They'll notice if something changes to add something, but oh, that one light is out now. That's harder to notice than that light just turned on, okay? And I'll give you a quick example here. So go ahead and pause the video and take a minute and look at this picture and tell me, why would Ferris introduce this picture? What's interesting about it? What's going on? And I'll just tell you one more thing, and then you can pause and unpause. This is a pretty big deal aspect of this environment. This is a weird, there's something strange going on here. Do you see it or not? Okay, pause, unpause. Now let me show you. You'll note now that I am drawing a line on the non-existent, I guess, seat bench here. So these three young ladies are, doing a bit of a trick, but the reason it maybe you didn't notice this at all, or maybe it took you longer than you maybe would have expected to notice this. And that has a lot to do with the fact that, number one, you're not looking for something that is there. You're actually looking for something that is not there. That is a more difficult thing to recognize or to have a bottom-up influence on. It's not capturing your attention. You know, if the background of this was like fluorescent, you know, orange or something painted, that would capture your attention in a salient way and help direct you to, oh wait, well, now that's not there too. But what we're talking about here is just the bench itself. The absence of that is sort of like, by definition, the lowest level of salience for something, okay? Now, the other reason it probably took you a while to find that is because of your top-down influences. So I'm just showing this to you, the colors, you know, the arrangement of the different, you know, patterns of light in this image. That's the bottom-up influence. The top-down influence is very powerful, and that is, all right, where do I expect to see something interesting here? And if I had eye trackers on each of you, and I you know, took the data and I reproduced it, I bet that a lot of you looked at this young woman, and this young woman, probably in that order, and probably at their faces. And probably that was the first thing you did within the first fraction of a second of seeing this image. And that's a good example of how humans very quickly parse a scene. And when they have an initial sense of, okay, the pattern of light over here is a human and it's a face, usually humans and faces of humans carry the most information in a scene. It's a very nice rule of thumb. If I'm going to look at any part of this picture right now in a split second and tell you what it's about, it's very likely going to naturally fall on the faces of these people, okay? Maybe you also thought, okay, well, no, nothing wrong with them. They're not my classmates. I don't know why Ferris is talking about them. Well, maybe let's look in the background. Is there anybody doing anything goofy? I got like a guy with, you know, on a unicycle or something. So you're probably looking around in the background. No, nothing there. Now, probably not many of you, at least consciously, would have thought, let me look at the ground by their feet. That is just generally not a place in a scene like this where you would find interesting or worthwhile information for whatever you're trying to do. So there is less motivation. There's a weak ability to direct our attention in a top-down sense because this is an unexpected thing. If you know, if this was the fifth image in a row where I was showing you people who were sitting on benches with missing or broken bench tops, then you'd have an expectation. Then you'd have a top-down influence that would say, look at the bench right away, and you maybe catch it right away. But absent of any of that sort of information ahead of time, you're going to go with what humans usually do, which again, where am I going to find the most information? Most likely, faces are a great bet. All right, so these are those top-down attentional influences and things we can think about for display and interface design. So if humans know ahead of time that a source is likely to contain a lot of information, that is going to, you know, motivate the orientation of their attention. Also, we're going to be interested in new things, novel elements, things that we're not familiar with, because by the fact that we're not familiar with them, that means they're potentially informative sources. Okay, so it's at least something we know is, sorry, it's not something we know is not important. There you go. So, you know, think about where's Waldo? What am I doing with this? So there's some context here I can pick up really quickly. You know, I can see a little bit about the, you know, the nature of this scene. I know the tricks that Waldo and Waldo's writer, I get Waldo's author, like to use to hide him. I think he's in here somewhere, but I honestly don't know. He's in here somewhere. But that whole process. So what sorts of mental pressures, orientation, influences are coming from, you know, in a search like this? It's going to be, well, where do I think there's information? Where's there usually information? You know, on the last puzzle I did, you know, Waldo was right in the middle. So I'm going to start by looking right in the middle. That's a good example of a top-down orientation influence. Often you will look at things that are next to each other more often than you'll just randomly sample, you know, bounce around this space. And all other things being equal, if I don't have any prior information that's guiding my attention or expectation, and I'm just going to search this scene, the rule that we go to when we have no other one is we'll start at the edges, we'll start at the top, we'll start at the left, and we'll scan left to right, top to bottom. And this is generally what you might see in a visual scene where there isn't any other guiding sort of, you know, information or knowledge beforehand. Now, some of you are thinking, okay, here we go. Some of you are thinking left to right. Why did Ferris highlight that? Scanning left to right, top to bottom. Because why not, a different pattern? Why does this describe humans in general? And then I'll say, oh, wait, it doesn't describe all humans in general. It describes most humans, because most humans on Earth follow a convention where written word, so language, proceeds from left to right. Okay. In English, that we do that. In most other, Romance languages, Western languages, proceeds from left to right. So what this basically does is our mental models of progress and of information processing involve this left to right sort of scanning bias. Okay. So if you're an English native speaker or another Western language, and I show you a scene and you got no idea what's going on with it, and you got to search it as quick as you can, pretty good chance you're going to start in the top left corner and do it like you're reading. So interesting, because not every language reads left to right. In fact, Arabic here, and so I don't know if it's all forms of Arabic, but at least when I say Arabic, nobody argues with me. It is written from right to left. And so this is going to be read, yes, top down, but from the right side to the left side. So this completely inverts, for certain cultures, their normal visual scanning patterns, and then also a lot of the norms about progress, right? So the way we think of things progressing in time is usually from left to right if it's represented visually, like in a maybe the cat's out of the bag on this, but like in a comic strip, right? So what you see here is an ad, that was, this is actually a character. It's like a paraphrasing caricature of the ad. But imagine we are, dying of thirst in the desert. We get our cola. Oh, now I'm feeling good. Now I'm up and running again. And let's now run this ad globally. And then in parts of the world that, Arabic may be the first language, or other right to left reading cultures, they're going to see this ad and they're going to see this guy, who's feeling great, drinks his soda, and then he dies. So this is an example. Actually, there's an anecdote of another ad. This is, again, just like a recreated one because we can't find the original ad, but this is something that, actually happened. Like, I think it was Coke had run an ad, in the Middle East, and basically showed, oh, if you drink our soda, you're going to have a bad time. All right. Okay. So, right. So moving along, let's, talk a little bit more about designing to guide attention. Selective attention is that variety we're interested in here. And people have like a basic, there are variances in people's individual abilities to select things. Selective attention is different based on people. So you may have seen this before. But I would like to play this, and I want to go through the full exercise here. What I want you to do as you're watching this, and this is actually just a test of some selective attention features, is I want you to watch all the players that are wearing white shirts and count the number of basketball passes that occur between those three players in white shirts, and try to shut out all the other noise that's going on. Just do the best you can to trace those three in the white shirt. So here we go. And you have to count the passes. You can check yourself at the end.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count?
How many did you count? And what's the answer?
The correct answer is 15 passes.
All right. So I hope you got that. If you didn't, you're broken. Oh, by the way, I'm leading a charade here. This is not this is not true. If you didn't see it, get ready.
Did you see the gorilla?
What? Yes, it's true. You can rewind the video and find out. Yes, there is a guy in a gorilla suit right there. Walks right through the middle of the screen. That definitely happened while you were just counting the passes around him. I told you, hey, try to
This
focus.
video is
Here we go.
from research by Daniel Simons and Christopher Chabris and is copyrighted.
That's right. We need to give them credit. And you can find more information. Daniel Simons is and Chabris, they're researchers at, I think, the University of Illinois, Chicago, maybe. But they're still producing similar sorts of research there. And what do we just see? Okay, this is an example of the power of top-down influences in selective attention and our ability to basically get in a certain filtering mindset. So I asked you, tell me all the passes amidst those in the white shirts. Now, I didn't say look at the part of the screen where the people in the white shirts are, because they were all over the whole screen. Your visual field of view couldn't be parsed into here's where the white shirts are and here's the black shirts. They're moving all around. So what happens is your visual attentional filter gets set to certain characteristics, like the fact that they're wearing white shirts. You're able to track a subset of those. And in order to do that, you are shutting out what you view as irrelevant stimuli, which mostly look like people wearing all black, right? So then when you've got a gorilla that's also wearing all black, it fits into that same category of stuff to be shut out and ignored that's noisy. And then you don't even notice it. And it's something outrageous like that. But you didn't expect it. And so your top-down influences, or maybe you've seen this before and you did expect it and then you saw it right away. But if you didn't expect it, I would expect you didn't see it. And so it can go unnoticed even within the field of view. We call this effect inattentional blindness. Definitely going to come up on something. So know about this effect. This is a failure to me of the interplay between bottom up and top down influences in attention, because it's all about what do I expect to see, and that being so powerful that it overrides any of the salient bottom up effects of something like a guy in a gorilla suit walking through. That stands out from the background in some ways, but not necessarily in the physical properties like we talked about. The color of the light that comes from that gorilla is the same as what comes off the shirts of those who you're trying to ignore. All right, so we are selecting from our scene important stuff to be ignored. We can maintain that mindset, but sometimes then the things that we think should be ignored are actually the important things, and then we end up getting interesting effects like this, which again we call inattentional blindness. So the way we deal with this is in cases where we know inattentional blindness might occur, which is basically we know if something unexpected happens, people are less likely to be looking for it or realize it happened. And so what we need to do is we need the system to amplify or really emphasize those bottom up properties, make that thing stick out from the background that much more. So this is a reason why hunters are wearing these gaudy orange, for example, because I'm otherwise not necessarily looking for a person as I'm walking through the, as I'm shooting stuff in the forest. And so then this really emphasizes the bottom up influences of, oh no, wait, there's another thing here. There's a person. Oh, I better not shoot. Police, sirens, for example, not just to get you, but like to gather the attention of everybody on the roadway so they know, to clear a path for an emergency vehicle. Sirens being loud, salient, and bright and colorful, salient, right? They're drawing attention in a bottom up way. Similarly, if this thing goes off, it. Everybody knows it. It's super, super loud. And that's another way of saying it's super, super salient. It stands out from the background. It's going to capture your attention. All right. So that's inattentional blindness. The way that we design for that is we emphasize those bottom up influences as best we can, but it's definitely something to know. I love to ask questions about it. Now, contrast, there's two effects I like to talk about with attention. Inattentional blindness is one of them. That's much more, in my mind, influenced by top-down influences, expectations, and things. This effect, change blindness, not inattentional blindness, change blindness, is a bottom-up influenced effect, okay? This is something that is basically tied into the mechanics of how our sensory system works. And so this describes that if you have visual events, and actually this exists in other channels too, other sensory channels too, but it's easiest to explain here visually. If you have a change in a visual scene, and maybe a really interesting change in a visual scene, like that light wasn't on, but now it is on. But if that change occurs at the same time as some sort of visual disruption, like I look away and I look back real quick, then you are much, much less likely to capture that change, to realize that change occurred, than if you were looking right at it and you observed it live. Now, that sounds obvious. Okay, if I wasn't looking at it, I'm less likely to have seen it. Yeah, that's obvious. But what might be not so obvious is the surprising difficulty and precision with which we can tune this effect. Okay, so for example, I'm gonna let you look at this for a minute. And what you see is two different images that are separated by a brief flash. And what that flash is doing is obscuring your visual pattern. So you cannot see a direct transition from one image to the other. And I'll tell you, if you could see that direct transition, this would be a trivial task to tell me what's changing. But if you take a minute, look at this, something is changing, something large. What is it? And why is it so hard to see? And I'll tell you why. So probably, again, top-down influences, many of you are going to be looking at this guy's face. You're going to look right at him. Probably the first one you saw. Next thing, probably looked at her, right? Probably followed his gaze to see, well, what's he looking at? Oh, another face. Good. Now, what else is interesting in this scene? Ooh, the food, the drink, right? Probably look down here. These are colorful. You know, so you got some salience here that's bringing you in. It's also the kind of location where it's likely to include important information. You know, your expectations might be, if there are people sitting at a table, there's something interesting on the table. What's not potentially your first thought of being an interesting thing to look at might be the safety rail behind these people. So you see this guy going up and down. Obviously, that doesn't happen in the real world. So this isn't something you have to look out for. But what this is showing is it's illustrating how, with this disruption, how challenging it can be to notice even fairly large changes in a visual scene. And again, that's because our visual system is so reliant on a certain time window to detect a change occurred. And if that time window is not letting us see that transition, it's like seeing two brand new images to our visual memory. All right, so where does this come into practical sort of applications? So I made this. I'm very proud of this, but I didn't make. Starboy made the puzzle, but I'm very proud of what I'm about to show you. So if you've ever done any of these puzzles, you know, like maybe in the Sunday paper or maybe like in a game station at like a restaurant or something, you might say, okay, well, I'm going to tell you there are 7 differences between these two images. And you're going to go like this woman. You're going to look at that one. Okay, I notice things. Oh, let me look and see if the difference is in this guy's hand. Look over here. Oh, there's the hand. No, it looks similar. Wait, I can't remember though. Did he have all 5 fingers up? I'm going to look back. No. Okay. Yep. So the difference isn't there. All right. Let's look at something else. What about the guy's tie? Okay. So he's got a blue tie here. Good. Look over here. So each time I'm switching back and forth, look at this. It takes me about 0.2 seconds or 200 milliseconds. That's a high end. But this is something called a saccade. A saccade is a rapid eye movement from one location very rapidly to another. So this is every time when I say, look at me, and you do look at me, that was a saccade that brought your eyes to me. So there are different types of eye movements. These are the very, very rapid, very fast movements of your eyes. They take about 200 milliseconds. And here's the really freaky but interesting thing. While your eyes are very rapidly moving in you know that extreme of an eccentricity, if you were taking in light information and your retina was processing things during that very rapid movement, I think we would be getting sick all the time. So what happens, your visual system actually temporarily shuts off. You're temporarily blinded during this very rapid movement of your eyes. It's called saccadic masking, possibly saccadic masking. I don't know how to pronounce it exactly. SACCADE is the word, and that masking, as in my eyes just moved, my visual system shut off momentarily for about 0.2 seconds. And then the imagery, when it comes back, might look very similar, but you may recognize I have just done effectively, while my eyes are moving, I am seeing two images separated with a visual obstruction, a visual disruption, which is the saccade, okay? So if you're doing this, you're like, why is this so difficult? It's taking me forever to see the 7 differences. All right, so let me show you how we translate this to a change blindness problem. So look back and forth, and that might do this to you. So here, I made this. All right, so get ready. I'm going to show those 2 images. I've overlaid them on top of each other, and they're going to basically have an like I timed it perfectly. I did it in the video maker and everything. So we know that I'm separating each of these images by 200 milliseconds, which is about the length of time of a saccade. All right, here you go. Ready? I have to click play. So these are different images. You take a minute, click it. You can watch this as many times as you want. I think I have it going for like a minute. All right, so probably still a challenge. Maybe you saw a couple things, maybe you saw a few changes. Oh, I see one now, and then it's hard to unsee it. But you may be surprised still how difficult is this. Now watch this. I'm gonna cut that time in half, 100 milliseconds. Okay, so this is like, some saccades are this fast, but this just kind of shows you the range. Now I'm still getting the effect, but it might be a little bit less now. Now maybe you're starting to see, oh wait, what was that? Oh, I'm starting to see things change, and they'll capture your attention because we're right on the edge of where humans can continuously process and have continuity across their visual experience. And so can see, oh, I see that change. Now, here's really the kicker. Ready? So I'm going to now show you with 0 obstruction at all, and watch how easy this is now. All right, there it is. Now, to me, things pop in and out. Now they become salient changes in the environment when they're no longer coinciding with that visual disruption. It becomes much, much easier to see where those differences are. So again, that is the concept of change blindness. It is a bottom-up influence. Don't confuse it with inattentional blindness. You should know both of those mechanisms and how they affect attention. And then how can we do anything about it? And we haven't talked about that with change blindness yet. So this is an example because, you know, there are a lot of, it's not just us doing these spot the differences real world puzzles. There are cases of, you know, visual comparison of multiple different, you know, images to see how things change over time. I've got some radiographs here of a broken bone. This is what it looks like as it heals. And so this physician may be looking at, you know, maybe he's got a light board and he's putting these radiographs up on it and saying, well, is it different from day 1 to day 3? And I'm now saccading back and forth, and I have a change blindness risk situation, right? So what do we do about it? Well, why not? And we can do this now with you know, high powered technology. Take these images, digitize them, and superimpose them on top of each other, and do this. Have them alternate very quickly. Essentially what I'm saying here in the design sense is minimize the visual disruption between one image and the image you're trying to compare it to. And one of the ways to do that, because we can do this very easily digitally now, superimpose them, and then do your best so there's no disruption, and you can switch back and forth between them instantaneously. It will make those differences pop out like that, you know, just like it was this easy, you know, to see the differences when we had them without that obstruction here. Okay, now one more subsection here. You know, audition and the other senses don't get nearly the playtime that you know, vision does. So there's a couple of, you know, unique ways that auditory attention works I wanted to point out. So in the same way that vision, you can talk about, here's all the sensory data, I'm parsing it, I'm going to process just this much. And just this much might not be that area of space, but it might be just the people wearing white shirts in my visual scene. Okay, so it's not necessarily just defined by a spatial location. It could be, you know, any of these other filtering properties. Same thing with auditory attention. So we use grouping principles to take the cacophony of sounds around us that are all combining in the pressure waves of the atmosphere around our ears and ultimately reach our eardrums and vibrate them. But how is it we take that huge explosion of noise all around us and we separate it into individual streams of, I can now hear each of these people singing if I focus in on it. I can isolate each instrument. I can separate these streams and process them in parallel, even though they're all coming in at the same time. And so one of the ways we describe this is what we call the cocktail party effect. So if you've ever been to a party, a cocktail party or not, and there are lots of people there, and the overall ambient noise level is high because everybody is talking, and then take a minute and think, I can probably hear about 100 different unique sounds at once here. How is it so easy for me to look at the person in front of me and hear what they're saying and have a conversation? So we call this the cocktail party effect. It's generally talking about the amazing human ability to shut out a huge amount of noise. And especially when it's, voices, like in a party, they're similar sounding noises, right? It's harder to separate them based on, things like, well, that's somebody mowing their lawn versus talking to me. No, it's multiple people talking. They have it's harder to separate those, right? In an objective way. So some of the principles we use, some of the ways that we group these things, the tone of voice, you can recognize somebody's voice by its sound, and that can help you stay oriented on that person. The origin, so if somebody is talking at you from a location, you can use that clue to group that stream and, you going with that person. Visual feedback helps a lot. So, when people can hear and see. So if you hide my video right now and just listen to me talking, you're not going to get as much out of the auditory processing as if you can also see the redundant, the additional cues of my mouth moving. It helps disambiguate words and things like that. Also, the semantics of something matters. So this is an example of a task you might see in a psychology lab called a dichotic listening task. And it's testing auditory attentional filtering. And so you'll have different messages going into each ear, and the experimenter would say, hey, why don't you tell me what's going on with George Washington, or what's going on with the horses, or sorry, Lincoln. And you can then follow semantically that thread. So you can lock in on, I'm going to listen to the Lincoln one or the horse one. The interesting thing is this can actually transition from one ear to the other. And there have been examples of, half of a story in this ear and a totally different half of a story in this ear, and then they switch at some point, and people are able to follow the semantic logic, between the ears. All right. I like this one. So what is there's one exceptional sort of stimulus to this cocktail party effect. So what I like to talk about is, I'm in this party scene, I'm talking to this person in front of me, maybe a couple people, and suddenly from across the room somebody says something that captures my attention. What is it? It's probably my name, right? So if your first name, or however you may be known by your loved ones or the people around you, your moniker is uniquely attention capturing to just you. And so this is something we call this the own name effect. And so if you ever hear, hey, my ears are burning, you're talking about me, that's kind of that concept, is when your own name is part of an auditory stream, your attention latches onto that much more powerfully than any other, like auditory pattern. I mean, you could yell like, hey, fire, or something like that, but that's going to capture everyone's attention. If someone mentions Tom across the room, even if I'm talking to you right here, a little bit of my attention goes that way. So again, that's called the own name effect. You can say that is the one interesting exception to these cocktail party effect grouping principles. Okay, so in general, this is looking more and more familiar these days, right? So if we have multiple auditory streams, like lots of people talking over a common channel, we now have technological ways to guide people and help them parse all of that noise and, okay, well, who is talking right now? So one of the ways is, well, I don't know if you knew this, but like Zoom, has the function to, well, switch whoever is in the main view based on whoever is speaking right now or speaking the loudest right now. We can also highlight, for example, like this, we got a large group. So this is directing attention. So I'm looking at this little portion of the stream. That's going to help me link it with the auditory stream that's going on. We can use auditory. So these are visual ways of assisting audition. We can also use auditory ways to capture attention. So we call these attensors. And the question is, these come into play a lot of times with alarms. So if I'm in a context like this, and I need, to tell somebody in that space there's a problem they need to orient their attention towards, it's a challenge because I maybe only want some people, but not everybody's attention to be drawn. And a good example might be if you've ever had a roommate who slept through multiple of their alarms like I did. And so now those attensors are capturing everybody else's attention in the house, but not this one. Just a joke, rip on my old roommate. So here's a question. Are there specific ways who I could capture just the attention of the anesthesiologist or just the surgeon or just the, whatever the role of the person who needs their attention oriented there? And I'd say, well, one way to do it might be to use the own name effect, right? So I always talk, well, what if I had a little alarm that just said, Tom, Tom, maybe like not that loud, so not everybody in the whole room is disrupted, but I have that hardwired secret loophole channel, to capture my attention if I use that person's moniker, their first name, or their whatever they go by. Okay, last slide here. So the other thing to consider is, especially when people are, multiple people are speaking over a common channel, like air traffic control, radio, CB, that kind of thing. This is where, using specialized language can really help. So this is the NATO phonetic alphabet. This is what you'll hear air traffic controllers and pilots speaking. They will not say, I'm flying in, in the aircraft 1702 TAM, which is, maybe a call sign for a Texas A&M aircraft. They'd say, I'm in 1702 Tango Alpha Mike, okay, TAM. And that's because words like E and G and D and V, all of these, when I utter them, my verbalization of those letters is too similar, and they'll overlap, and they'll be that much more difficult to parse out. So we say these, these longer words, but they're more differentiable from the background. Finally, going all the way back to talking about the difference between audition and vision, one of the things we talked about is you can hear things, but auditory stimuli exists in time and then it's gone. They're transient. And so if I'm sending a verbal message, one of the best ways to help support attention to that message, which is delivered auditorily, is to supplement it with visual representation. This is going to help me understand the lyrics of Elsa that I'm hearing when I can also have the additional clues, from the visual, the persistent display. All right, that's it. Thank you very much, everybody. That's 8.2. All right, so next topic will be on memory. All right, thank you.